Welcome back to some more geometry. Today we are talking about congruent triangles. So, in case you forgot, congruent means two figures that have the same shape and size, okay? Now, when we're talking about congruent polygons in general, it's just when all the polygons, when all the parts of one polygon are congruent to the corresponding part. Now, the corresponding part's important because we're used to just saying, oh, these parts are all the same, but what parts are the same? So, let's look at this triangle right here. The same triangle XYZ and ABC are congruent. That means in that specific order, they're congruent. Those individual parts are congruent. So there's a total of 6 parts. There are the 3 angles. So angle X and angle A are congruent. Angle Y and angle B are congruent. And angle Z and angle C are congruent. Now, also, that's the 3 angles. Now let's talk about 3 sides. XY right here, that's congruent to AB as it states, because it's in that order, X, Y, A, B. Now, so if I say Y, Z, I'm not going to say C, B. Even though it's the same side, it's not properly stated. You have to match up the 2 sides. So Y to Z is as B to C. And then CA is to ZX. So that shows right there. So for a triangle to be congruent, all 6 parts have to match up. That kind of states like, oh, all the parts are the same, so the triangles have to be congruent by definition, because the definition of congruent triangles is all the corresponding parts are congruent to each other's parts. So for example, here we got a pentagon ABCDE and RSTUV. So if I'm talking about side AE, that's congruent to which side over here? It's RV, not VR, because we have to match up the angles as well. A is to R, E is to V. AB is to RS, and so on all the way around. Now, this kind of leads to our theorem for the day. We're really talking about one theorem. This is it right here. So this theorem says if I have 2 angles on a triangle congruent to 2 other angles of another triangle, then by default, the third angles have to be congruent as well. Now that's true because there's only a finite number of degrees the triangle to have, and if 2 of them are exactly the same, then the third ones have to be the same because there's only 3 in the triangle. This kind of leads to this right here. So if we know, now this is the important part, the corresponding part. So we'll get to that. So when we get to further on in the chapter, we'll learn that all it takes is 3 parts of one triangle to be congruent to 3 other parts of another triangle. So if we know that 3 parts of one triangle are congruent to 3 parts of the other ones, that proves that the triangles are congruent. And since we now know the triangles are congruent, we can go to assume that every other part, so all the corresponding parts of the congruent triangles are congruent. We call that corresponding parts of congruent triangles are congruent, or for short, CPCT are congruent, or CPCTC. These right here, these will be used when it comes to 2-column proofs and we're trying to prove certain things are congruent, whether it's angles or sides. That'll be our reason once we prove the triangles are congruent themselves. And we'll explore that further on. But let's get into the examples for today. So in the examples here, we know that KJL and YXZ are congruent. That means angle K matches up to angle Y, and then side JL matches up to XZ. So when it goes to solve for X and Y, go ahead and solve for X and Y. Take a minute and do that. So for the angles, since they match up, we can say Y plus 4 equals 2Y minus 15. When you go to solve it, you end up having Y equals 19 because we added 15, add 15, that goes away, and then minus Y. End up having 19 equals Y, or Y equals 19. And down here, we got 2x minus 3 equals 5, since those 2 sides equal. So we add 3 to both sides. We get 2x equals 8, and then divide by 2, of course. You're getting x equals 4 on this one. Here's another one. So take a minute to pause and do this one on your own. All right, so ABC is congruent to EDC in this case. So that means that AB, this whole side, is congruent to this side down here, the 20. So we go 3x minus 10 equals 20. And we go to solve it, you end up getting x equals 10. You add 10, you got 3x equals 30, divide by 3's, you get x equals 10. Now when it comes to y, we're talking about this angle right here. Now this angle right here is vertical to this next one down here. So now we look at this triangle. We have two of the three angles. So we have the 90 and the 36.87. We add them up, we get 126.87. We're going to subtract that number from 180 because, again, the sum of the three angles is 180 degrees. We end up getting 53.13. We've done properly. Degrees. All right, last example. Now, this one you don't have to write it down, but we're going to do it. We're going to get back in the groove of doing proofs. So we're going to prove that these triangles are congruent. So right now, the only method we can prove the triangles are congruent is to prove that every individual part are also congruent to each other right there. So they give us three parts right now. They tell us that J and P are congruent, angle J, angle P. JK and PM are congruent, JL and PL are congruent. And they tell us that L bisects segment KM. So we're going to start that. That's our given information. So we're going to go ahead and piggyback off this last one right here. Since L is the midpoint of this entire side, what's the next thing we can say about those two individual sides? Yeah, we can say that KL is congruent to ML because knowing that L, the bisector, that's the definition of segment bisector. Segment bisector. That's what a bisector does. Cuts it into two equal parts. Bisectors. All right. All right. So we got this side to this side. Now we need the angles. We got the three sides to three sides. We got one angle to angle. We need the other two. K will be congruent to M, but we got to prove that a different way. So let's start with L. These two angles across from each other, they're congruent. Why, y'all? Why are they congruent? Yeah, they're vertical angles. So, I mean, they're true because vertical angles are congruent. But we can't say angle L is congruent to angle L. No. What we're going to say is angle JLK, so J to L to K, that makes this angle right here. That is congruent to what's the other side? Relationally, it should be PLM. That's the proper order, PLM. And for 4, the last one, now that we know that these two angles are congruent to these two angles, we can go ahead and assume that the last angle is congruent to the last angle, Y class. Well, what was the last theorem we just wrote? Angle K is congruent to angle M. We talked about how the third angle theorem, yeah, that proves it. So now we know that the triangles are for sure congruent to each other, triangle PLM, because the definition of congruent triangles. By definition, since all 6 parts match all 6 parts, they are congruent. All right, y'all. Hopefully that helps. Have a great rest of your day. Bye.